Welcome back. Up until now, we've talked about topics that are definitely important, but they won't really affect your day-to-day coding. And you won't get really asked about what we just learned about interpreters and compilers in an interview. But starting in this video, we're going to learn about something that will come up again and again in your career that's very important and foundational to JavaScript, that any senior developer should know. And it's also something that we're going to keep bringing up over and over throughout this course. So make sure you pay attention. And up to this point, you might have wondered why I ignored completely this little pink and orange box, the call stack and the memory heap. And good, you've been paying attention because we're going to talk about this over the next couple of videos. You see, we learned that the JavaScript engine does a lot of work for us. But the biggest thing is actually reading our code and executing it, right? And what do you think the two most important things in this step are? That is, one, we need a place to store and write information. That is, to store our variables, our objects, our data of our apps. And a place to actually run and keep track of what's happening line by line on our code. Well, we use call stack and memory heap for that. We need the memory heap as a place to store and write information, because at the end of the day, all programs are just read and write operations. That way we have a place to allocate memory, use memory, and release memory, that is to remove it, just like these cupboards over here. And two, with the call stack, we need a place to keep track of where we are in the code so that we can run the code in order. And with these two things, the JavaScript engine is able to do that. So to review, the memory heap is where the memory allocation happens. And the call stack is where the engine keeps track of where your code is in its execution. But enough diagrams, let's actually show you an example. When we look at call stack and memory heap, well, if we write a simple const number equals 610, what we're saying here is please allocate memory for the number variable and make this number variable point to, in memory, in our memory heap, the value 610. If we do, let's say, a string, it's the same thing. We're going to tell the engine to, hey, please allocate memory for a string variable. So now, whenever we use string, we can say, oh, go into our memory. String is pointing to somewhere in our memory to this value of some text. Another way to think about it is if we have an object that is going to equal first name is going to be Andre, and last will be my very confusing last name that nobody can pronounce, Nagwe. And all we're telling the computer here is saying allocate memory for an object and its values. So now we're telling the JavaScript engine, hey, I'm going to assign this human variable, and this human variable is going to point, anytime I call it, to a region in memory, in our memory heap, that has these values. The first and last key that point to Andre and Nagwe values. To review, our memory heap is simply a free store, is a large region in memory that the JavaScript engine provides for us, which can be used to store any type of arbitrary data in an unordered fashion. There's no order to this memory. It just allows us to use variables to point to different storage areas, just like a little cupboard here. And a lot of science goes into optimizing the way space is allocated here, but we don't need to worry about that. We know that the engine takes care for us to put data into storage boxes for us. And that's pretty easy, right? Memory heap is not that hard. Just a place for us to store our information. But what about the next one? Call stack. How does that help us? Well, if we go back to our code, let's write some code here and we'll create something very simple. We'll have a function that will be called calculate. And this function will have a sum total that does some random calculation like 4 plus 5. And it's going to return sum total. It's going to return 9. So as we know, this function is going to be allocated to memory so that anytime we call calculate, it's going to look in memory and see, oh yeah, calculate, I have it right here. Here, run this piece of code. And every time we run this code, calculate, we use the call stack. So we can think of call stack as a region in memory which operates in first in, last out mode. What does that mean? Well, when we run calculate, we simply, on our call stack, it's going to just add the calculate function on top of the stack. And after we finish running this function, it's going to remove it. Now, to make this a little bit clearer, let's add another function to here, and then we're actually going to run this in Google Chrome to show you what's happening. I'm going to create another function called subtract 2, and it's going to take a number as a parameter, and we're going to just return num minus 2. Just going to subtract 2. So that in our calculate function, we can just return subtract 2 and give it the sum total. So it's going to subtract 2 from 9. So it should give us 7. Now, let's see how the call stack is going to work when we run this function. I'm going to copy this and go to our Google Chrome developer console. Now, I'm going to click on sources here, and you might have to click on this arrow to go to snippets. And I can just add a new snippet here. And as you can see here on the right-hand side, I have something called call stack that will show us what's happening. If I copy and paste this code, let's see what the call stack does. I'm going to add a debugger statement in here, which is going to pause the execution right here before I write calculate. And let's hit run and see what happens. All right, we've paused our execution, as you can see here, before we've done calculate. So the JavaScript engine has gone through this piece of code. I see that, okay, we've declared our functions. The JavaScript engine knows what subtract 2 and calculate is, and it has some place in memory that it stored this information, but we haven't run anything yet. But on the call stack, I see something called anonymous here that we didn't see before. What is that? Well, that's the global execution context, and it's something that we're going to talk about in the next section. But for now, it's anonymous because there's no name for this file. This is the JavaScript engine saying, hey, I'm running this file. This is the first item on the stack, and the first action that we take is to run this file. If I click on this down arrow, we will see that we get to calculate. That's the next step in the JavaScript engine. And if I click down again, see what happens to call stack here. The calculate function just got pushed on top of the stack. So our call stack now has the anonymous function, which was the global execution context, which was the main run of our file. But now, because we've run a function, we're inside of this function now. On top of the call stack, we have calculate. If I go next, I see that I've calculated the sum total, and the next line is going to be subtract 2. See what happens to the call stack here. If I click next, we're now inside of subtract 2. Another function was called, and we push another item on the stack. Now, here's the interesting part. We are not done with the calculate function, are we? We're still inside of this calculate function, and because this calculate function called subtract2, we're now inside of subtract2. I know, kind of confusing, kind of like Inception, but that's what's happening here. The call stack tells us, hey, right now, where are we in the code? Well, we're at subtract2. Once we're done with subtract2, then we can go back to calculate. And then once we're done with calculate, then we can go back to the global anonymous function, which is what happens in line 11 here once we finish our work. So watch, if I click next, the subtract2 is now going to return num minus 2, and the call stack, the subtract2 gets popped off the call stack. We're now at calculate, and we have sum total, which is 9, and we know what subtract2 is. That is num minus 7. So if I go next, calculate gets returned, and if I go next, we're done with the function. Look at that. Our answer returned 7. And that's what a call stack does. The call stack stores functions and variables as your code executes. At each entry, state of the stack, also called the stack frame, which is the frame over here, these 3 stacks, allows us to know where we are in the code. And it runs in a first in, last out mode. That is, the first one in is the last one getting popped out. And we can keep adding to the stack, and eventually it pops all the function calls until we are done with our commands. And we use the memory heap to actually point to different variables and objects and data that we store so that we know where to look. And by the way, this is the way it works in most programming languages. We have call stacks and memory heaps. And these are the 2 locations that JavaScript remembers items. Now, since every JavaScript engine has different implementations, where variables are allocated is not 100% the same all the time. So a good way to think about it is this. Simple variables can usually be stored on the stack, and we'll learn about this later on. And objects, complex data structures like objects, arrays, and functions, which we're going to talk about, are stored in memory heaps. The cool thing about call stacks is that it allows JavaScript to know where it needs to be in the code. Whatever is on top of the call stack is where JavaScript is running. How genius is that? One last thing. If we go back to the function that we had, and let's say this time around, we're just going to return sum total and not going to use subtract2 function at all. Instead, we're going to run calculate twice. What do you think is going to happen? Well, if I run this code, we have our global execution context. We hit next because a new function was called. We added to the stack on top. There we go. And now we run through this code and we return 9. And the call stack calculate function gets popped off. We're done with the function. And then we go on to the next line, which is line 11. And once again, we call this function. As soon as we call a function, it gets popped or pushed onto the stack. It runs through the code and then returns. And it gets removed from the stack. All right, we've gotten that part. Now let's get into a fun video where we try and break this and cause a stack overflow. I'll see you in the next one. Bye-bye.